Okay. Good morning, everyone, and welcome to the BBSim and Scalability Brigade for March 19, 2020. We have just three items on the agenda for today. The first one is just a heads up that the transaction patch that Ken worked on has been merged yesterday morning. I haven't checked yet to see if that makes any difference in the numbers compared to the test we did before or not. I'll look at that after the meeting and I'll send it out on the mailing list in case we see some differences. The second topic is around Casca partitioning. Remember, this has been around for a while. William Korkian and Mahir and Serkan started discussing this, I think it was back in December. And we have now a functional implementation of this feature. We did a single run yesterday. It was the first time this job with 512 ONU succeeded. And if you want to take a look at this run here, you can get the logs and the numbers. But to make it short, running with 512 ONUs with 8 instances of the OpenONU adapter, all the devices were enabled in Volta in 117 seconds, and all the ports were discovered in ONUS in 256 seconds. So I will say this is a great improvement compared to the numbers we were seeing for 256 with a single adapter. We'll need to investigate why there is this big difference between the devices getting activated in Vault and the port reported to ONUS. Shooting in the dark, I would say there are two possibilities. One is that the logical device takes a little time to add the ports to the logical device, and the other one is that the OS agent takes a longer time to report them to ONUS. Note that this run was still done with the Python version of the OpenFlow agent, and also this run was done without Ken's changes in the core. Is there any question about it?
So what does average ONUS time means compared to average Volta time?
It's generally pretty much 5 seconds longer. If you look at all the other results, yeah. There are a few cases in which it's different.
Yeah, no, what I meant is like, what is the difference in terms of like when you're calculating that?
Oh, okay. In Volta, we check that the device state for all the news goes to active. In ONUS, we wait to see the port to go in active state.
Okay.
Enabled state.
Yeah.
In ONUS.
Yeah.
So the ports have to show up in ONUS and they have to be enabled. And in Volta, the devices have to be active.
Okay. So usually, once a device gets active, for example, an ONU device gets active and a corresponding logical pawn, unilogical pawn get created on the logical device, and a status gets sent to ONUS. So usually those are fairly quick.
That's right. So if you look at the other runs, the numbers at ONUS and Volta are very close to each other. Yeah. The only time we have found such a huge discrepancy, almost double the time, is in the run. So it needs more investigation. What's going on?
Yeah, it looked like there's one thing that is like that it's slowing down everything. I have no idea what it is. It would be nice to see that.
So I think before spending too much time investigating this, we'll need to schedule this run, and I need to port the small and ugly patch I made in the core to get it working on top of the transaction patch. Because otherwise it makes no sense to investigate numbers that are basically based out of an old core.
Yeah, correct. Makes sense.
So I'll start the to-do list and let's take this up.
What's the mapping of ONUs to ONU adapters? I mean, is that just a fixed relationship?
So probably Serkant or Mahir can answer this question better. I believe that is a uniform spread across the adapters. So having 64, having 512 devices and 8 adapters, we should have around 64 on each adapter.
Okay, thanks. Yeah, so I think we'd seen that 128 was, you know, a pretty solid number to get handled by an ONU adapter, right? So I guess that's well within the.
Actually, I think we believe 200 is a pretty solid number.
Oh, so okay, so that was kind of the cutoff point where it started to.
Well, so 200 is very nice and stable and gives us the same numbers every time. 256 shows a little variability. So, yeah, I guess 200 is as good a number we'll get.
Okay.
Yeah, so the 200 is good for an adapter, single adapter.
Yeah, 200 is always stable in that ballpark between 120 and 140. That I will say it's a very acceptable range to activate when used.
Right. Okay. And this is basically it's a 32-way split on all PON ports. So if you went to 64, that should be well within our view of what the model would be per ONU adapter, right?
Yeah, that's okay. 64. That is very stable as well, of course, and faster than the 200. So yeah, I think as long as we stay with less than 200 devices per adapter, we should be fine.
Okay.
So the next topic we need to discuss on this is how to handle the ONU adapter restart in this multi-instance case. I know Mahir and Serkant asked me to put this point, so I'll let them talk about that.
Okay, just a quick question on the previous topic, sorry. So is it time to start moving towards doing the full configuration of a service on the automated testing? Are we still try to improve the performance of just the discovery and the port enable?
Yeah, I think it's definitely. Okay. I think it's definitely time to start building support into the pipeline to push the flows and check the other thing like authentication and DHCP.
Okay, that'll be interesting.
So it's at least to give the pipeline the ability to do that and maybe move one of the jobs that we know we can arrive to do the full test. So maybe moving the 128 or the 64 units per adapter to a full scenario.
Right, because we still want to improve the performance when just using one ONU adapter, we know there are some things that can be improved, right? They're all in the to-dos on this document. So even with a single ONU adapter, we want to keep improving the performance. So those jobs will continue. And we want to see those numbers, try and improve those numbers. And at the same time, we will explore more. We've really only done one run with the multi-ONU adapters. So we need more exploration on that front. And yeah, we'll start looking at pushing flows as well. So step by step, there's things you learn at each step, right? So
yeah, right. I guess so. We still have the transaction patch to bring in, right?
In the multi-ONU adapter case, yes. I think Matteo was saying that he already tried the transaction patch one time. Did you?
Sorry, it was muted. We tried the transaction patch last week, and we got some number, but that was not with the multiple adapters. Because for the multiple adapters, there is still a very small patch that you need to make in the core to support the registration of multiple adapters. That's actually a workaround. Mayer and Serkant are working on a clean patch, and when I did these changes in the core, Ken's changes were not in yet. So I'll need to rebase my changes on top of master and run again the test with 512 ONU.
I tested the transaction change that Ken made, but I didn't also test it with the multiple ONU patch.
What is this transaction patch? Is it the asynchronous messaging you are talking about?
Yeah, that's the one.
Oh, okay.
So especially in a scenario when the adapters are way faster, I think that patch will have a significant benefit in the entire scenario. So I'll make sure to rebase my changes on top of it today and make at least 4 or 5 runs so that we get some meaningful numbers out of it.
Okay, but when you tried the transaction patch with a single ONU adapter, was there anything else that was missing on that one? I mean, the performance was pretty much the same as what you had before, right?
Yeah, they were pretty much the same. I'm not entirely, because this was based on an image I built when the patch was still in draft. I'm not entirely sure this was tested in combination with the improvement in the route calculation.
The improvement in the route calculation happened before the transaction patch.
So the patch was pushed before those improvements started, and I don't remember at which point I got it to build my image, if it was rebased on top of master or not.
Okay, so what you're saying is we need to try out current master for both single and multiple ONU adapters.
Well, yeah, current master for the single ONU adapter is already running. I haven't, I just didn't go and get the result. But if we look at our job and we look quickly at the plot, I think it's pretty much the same. Because from yesterday morning, it was merged, so the last 5 builds here are running with that transaction patch in place, and I will say it's safe to say that the performance are pretty stable.
So this is with 256 ONUs, right?
Yeah, that's correct.
Yeah, so that's the problem with 256 ONUs. We get this variability in the numbers once in a while. Well, if you look at the 200 ONU plot,
we
it's a
still
lot
get,
less.
Oh yeah.
It's some, but there's no spikes.
Yeah, it's not as much as with 256.
Mm-hmm. Okay.
But the last, so the last 5 runs on this one also are with the transaction patch.
Yeah. So the job always run on master, so you get whatever is merged. The transaction patch was merged in the morning of yesterday. So I will say either the last 5 or the last 4 are using the transaction patch.
It doesn't really look hugely different, right? And so that's saying that because the transaction patch allows things to run asynchronously, i.e. concurrently, I guess, for some flow actions, right?
Yeah,
I think we have, irrespective of the transaction patch, I think we have reached a limit of how many ONUs we can get from when you adapt. So and that looks like to be around 200.
Yeah.
And no matter how much we try to improve the core, that's the limit that we have reached for adaptation. It's really,
yeah, I think that's why it's important to try the current master for the core with multiple adapters, because in that case the core will have to handle a much bigger number of messages, and we may see that this difference gets much smaller.
Okay, so that's why you're saying that the benefits of the transaction stuff may actually be seen when you have multiple ONU adapters.
That's correct.
Okay.
Because we suspect that at the moment the bottleneck is the single ONU adapter again. It was the core for a little while, then with the route computation improvement, the ball went back on the adapter side.
All right.
Okay, so the important topic that we wanted to discuss today is how to handle the adapter restart. I'll let Mayer and Serkan talk about that in a little bit, because before going there, we thought it was important to spend a few minutes going through an overview of how Casca managed the partition in a topic and the consumer group, because that's always a little fuzzy and takes a little bit to understand. So I prepared a few slides just to quickly go through the process. Starting from the very simple case, we have one producer, one topic, with one partition, and one consumer with one consumer group with a single consumer. This is pretty straightforward. Everything that the producer produce goes in the same partition and goes to the only consumer available. When we have one producer, one partition, but multiple consumers, what happens is not that the messages in that partition are round robin between the two consumers, but they all go to a single consumer, and the other one is there just for backup. When we have a number of partitions in a topic that are the same as the number of consumers, then all the messages that the producer sent to one partition will be delivered to one consumer, and same with the other. Is the producer that chooses how to split the messages through the various partitions, and that can be done statically specifying the partition ID, or different hashing algorithm included with various Casca libraries can be used. and each consumer receives only the messages to the partition is associated with. The way a consumer is associated to a partition is decided by Casca itself. In the case in which we have more partitions than consumer, then again, Casca decides how to associate a consumer to a partition, and we may have a consumer servicing multiple partitions while others are getting less load. So the only way to guarantee an even spreading of the load is to have an equal number of partitions in the topic and consumer in a consumer group. This is not really useful in the Volta case, but just make it complete. When you have multiple consumer group, that actually means that the messages are duplicated. For example, when a producer sends a message to partition number 1, then that message is duplicated and sent once to consumer 1 in this consumer group and once to the consumer 1 in this other consumer group. And which consumer receives the message depends on the same partition consumer ratio as before. Now, this is to introduce a little bit what happens when one of the consumer gets restarted and comes back.
Wait, hold on. Before you go to restarts,
yeah,
can you put the previous slides in context of Volta and the adapters?
This one?
Well, any of the previous slides, right? Can you put in context of, okay.
Well, this is the case I've been testing with. I've been configuring Casca with 8 partitions and running 8 consumer groups. 8 consumer, meaning 8 instances of the OpenONU adapter. So each of them was getting an even spread of the load.
Okay,
the producer.
Yeah, go ahead.
The producer is now configured to use an hashing map. So basically hashes the device ID and use that to send the messages always to the same partition.
Okay, but go to the previous slide, the one before this one.
This one?
Yeah, was this slide number 2? Or
yeah.
Yeah, okay. So
Oh, I am thinking that I think this is not correct. If there are multiple consumers, then I'm not sure. Okay.
there's only one partition, so it only sends it to one of the consumers and the other one is just sitting around doing nothing. Okay.
Yeah.
I'm
Okay.
just wondering if it's everyone sits around gets nothing, or one of them they alternatively consume from that partition.
No, it's not round robin. At least in my testing and from what I read in documentation, if you have more consumers than partition, then some consumers are idle. And this is actually what I was seeing during my 4th run, in which I wasn't getting any ONU active, because I was running 8 instances of the OpenONU adapter, but Casca was still configured for a single partition, and I was actually seeing one single device, one single adapter getting all the load.
All the load of 500 ONUs.
Yeah.
Okay.
So the other 7 were just sitting there doing nothing.
Okay. So now go to the next slide. So in this case, the number of partitions is equal to the number of, say, ONU adapters. And you're saying it's a hash by device ID. So
yeah,
the same device ID always goes to the same ONU adapter.
It goes to the same partition.
I messed that up. Yeah, the same with the same device ID goes to the same partition, so it always ends up at the same ONU adapter.
Yeah, assuming that the adapters did not restart, it goes
Right.
to the same adapter.
And then
Yeah,
what was
that
the
is the
next?
implementation choice.
What is the slide after this one?
This one is a case in which you have more partition than consumers. And still, as long as the adapters or the consumers don't restart, you'll always get basically a consistent mapping between the device and the adapter. Because whatever goes on partition 1 and 2 always goes to consumer 1, and what goes to partition 3 always goes to consumer 2. And it's based on the same hashing mechanism.
Okay, so this just means that some ONU adapters could end up with more devices to handle than others.
Depending on the configuration, that can be the case. But if you decide when you deploy how many adapters and how many partition, so it's up to you.
Right, okay.
For example, you can start with 4 partitions and 2 ONUs and 2 ONU adapters, because that will service your scale. And being the number of partition even, they'll most likely be allocated 2 on the first consumer and 2 on the second consumer. So you still get the same load. So this is just something to be aware of when you define how many partitions you want on Casca and how many adapters you want to run.
Okay. And then the next slide you said is not our case, right?
This
because
is
we don't.
Not our case for now, because we only have 1 consumer group per topic. But in case we want to move the alarm reporting outside, this can be a way to address it.
This is what we were using when we had 2 cores acting in a pair, so that both core can get the same message at all times.
Mm-hmm. I see. Yes. Okay.
Okay.
Sorry. Now that you put it in context, now you go ahead. Yeah. Thank you.
Okay. Thanks, sir. So when we restart or shut down a consumer for any reason, what happens is that the association between the partition and the consumers is being calculated again, and so the message will be distributed across the remaining consumers in the same group. Now, there is probably an algorithm that decides that, but in my testing, this looks pretty random. It's hard to predict. So I will say, for the time being, there is no way for us to control which consumer will be associated with which partition. And yeah.
So the consumer 2 is still there, but the association between the partition 2 and consumer 2 is also changed in the picture. Is that correct? Is that the case?
Can you say that again, Mahir?
So the consumer 3 is restarted in this picture. So the consumer 2 is still there, but you change the assignment of consumer 2 to partition 2 also.
Yeah, I've seen this happening in my testing, because when only 2 consumers are left, it's not always that only partition 3 gets added to 1 consumer. Sometimes they completely change.
Okay, interesting.
Yes, when the consumer 3 come back, the partition distribution will be might be totally different.
Yeah, it might be this case, or partition 3 may go to consumer 2 and partition 2 to consumer 3. It's I've seen happening a little bit of everything.
Is that a choice? I mean, are there any other choices in Kafka to keep the remaining association and only change?
There is a solution for that. It's a new one. It's called as sticky partitioning, but I don't think all of the Kafka libraries support that. Yeah, that one.
this is the one. Anyway, I'm going to share the presentation on the mailing list and put it in the Design doc after the call, so everyone is welcome to go back and you'll find the link.
Okay.
Anyway, yeah.
So this is my take on why the consumer restart effect also, but as I said, I'll leave Serkan and Meir talking about this because they are way more experienced on this field and they put a lot of work into it. Sean, did you have a question?
No, yeah, actually I had one question. If you go back to the slide that shows one adapter dying.
Yeah.
What if those arrows from P2 and P3 did not reassign to C1 and C2? What if they stayed on C2 and C3 died and it comes back and then resumes, just like we have with the single adapter case today, right? I mean, adapter it dies, it gets respawned, it reconciles. But the assignment between P2, P3,
yes,
and C3 doesn't change. Is that what you mean by sticky partition, or it will always change and then it'll come back, flip back to C3 when C3 comes back?
Yeah, it will be a flip. So yeah, when the C3 dies, so there will be a rebalancing. When it came back, the associations will be the same as before if you use sticky partitioning.
Okay, so now I understand sticky partition, that when it is dead, things are going to change. But
yes,
when it comes back, it'll come back to where it was before. But my question is, can you prevent the change from happening in the first place, right? When it's dead, then let it not work for some time. Don't rebalance. And then let it come back and resume from where it was before, basically resume by reconciling.
I don't think we can do. No.
That's not
I don't
possible?
know.
Okay.
I never see.
Mm-hmm. But that's a
in general, like
that would be a valid way to do things, right? In the sense that it's no worse than what we have today with a single adapter. Single adapter dies, things are on pause for a while, right? Until it gets respawned and it reconciles and then goes on with life.
Okay, can you shut down topic P3?
No, you can resizing the partitions at runtime is very tricky. And also, if you remove the partition P3, then the hashing map that calculates where to send the message will be recalculated, and so the message for P3 will be actually sent to P1 and
P2. The way Kafka does the partitioning and the way consumer group was originally built, it's really for totally stateless consumption.
Right.
You can have like a X number of adapters. They are one consumer groups, and one goes away, it's fine. Everyone can handle it. Right.
So ideally, that would be the way it should work.
Yeah.
But we'll have to work harder to make sure that it works in this scenario, because while Matt has worked to put state into etcd, maybe we can get through it, right?
If we can always get something from etcd and always put the latest state in etcd from the adapter perspective, then it's then we're good.
Yeah, but latest is questionable, right? I wish Matt was in this discussion. But C3 dies, P3 rebalances to C2.
Matt is in this discussion, sort of.
I'm here.
Oh, you're here.
So, yeah, so a couple of things. One, always reading from etcd for every call. That's back when we had external MIB storage, and it was always a just-in-time read and write for everything. and our performance was abysmal. We had to pull it out within a day because it was terrible. Now, if we move to a Golang adapter, that may not be so bad, right? It would be more like what the core does itself, always being able to work with etcd in real time or near real time and not have a problem. But with Python and Twisted and etcd calls at the time blocking, it was a non-starter. That's the one point. The only other point I wanted to make was I think part of the reason why we came up with the scenario for multiple separate topics, each with each consumer working with its own topic, and ahead of time, basically by edict saying, we will not be rebalancing, we will not be repartitioning, because every consumer and every topic for the three of them will always stay separate. I think that's part of the reason why we started exploring that path, was to avoid this state of one is dead, but it hasn't quite come back yet, and then the other two are getting messages that really aren't meant for them, which really means they shouldn't even be on the same topic at all.
But can you actually disable the rebalancing?
Well, and so this is where I wish William was here, because he worked with it more, but I think the summary version was, we don't have one topic, we have 3 topics, or we have 10 topics, and we have 10 consumers for 10 topics. And ahead of time, as part of environment build out, we build out what we expect the capacity of this pod to be based on how many ONU adapters we're going to run, and based on how many topics we create for any one of those ONU adapters. And then again, just now the producer in this case would just have to know which topic is relevant for which ONU adapter, which consumer.
So instead of partitioning a topic, you're just going multi-topic.
Yes, I think that's where we left it. There was, again, it was conversation maybe about 4 months ago or so. But I think where we ended up was it was just easier, rather than trying to fight with the algorithms of Casca and rebalancing, to just treat them as separate topics. And then basically through build time, environment setup time configuration, we separate them.
It's a simple approach.
Right, and this is what got us there. This is kind of why we kind of threw our hands up and said, why have the same topic if really messages in the one topic aren't really meant for the 3 consumers 1, 2, and 3, because they're really not. C1, C2, and C3 aren't meant to handle each other's messages. They're meant to handle their own messages.
And so to add to what Matt is saying is the very first time on the first communication for a device, so it can be done of every single device, when the request comes in, it can also say, I'm sending you this message on this topic, and please reply on that topic. And that topic can be dynamically changed. So if a device has changed from one adapter to another adapter, which has a different topic name, then it will just reply, says, send me back on that new topic instead of the previous topic.
Yeah, I think that's worth noting in these pictures as well, is the role of producer and consumer. There's the reply topic as well for messaging in the other direction.
Yeah, in the other direction, the consumer and the producer actually flip in this picture, because the adapter becomes the producer and the core becomes the consumer.
Yeah, I like at one point of time, I was experimenting with having a topic per device, and then I had to go to take that away because Kafka was having problem handling that amount of topics. But topics per adapters, when we have a limited set of them, that shouldn't be a problem.
So just out of curiosity, how many topics were you trying to create when you saw issues?
I think once you start to get to be above 1,000 topics on Kafka, even if the documentation on Kafka says, oh, it's limited and everything, but once you start to go beyond 1,000, thing doesn't work that way.
That's interesting.
Especially dynamic creation. Like if you do static creation, it may work better, but dynamically it's slow.
Okay, so it was actually taking a lot of time to create the topic.
Yeah, because it created, and then when you have multiple partitions, it needs to make sure it goes to to all of them. There's a lot of rebalancing that's happening on Kafka before it tells you like, yes, it's ready.
So what's the issue with redistributing the traffic to a fewer number of adapters, right? It's just that, I mean, it's still going to do the same thing, right? It's just, you're just moving which adapters handling which ONU.
Yeah, but depends, right? You'll run into a lot. If you're not storing really everything every time in etcd, then suddenly, just go back to the previous slide. It's easier to explain with pictures. Suddenly C2 is getting stuff that it was not dealing with before, right? So it might try and pull state out of etcd for this new device that has suddenly showed up on, for which messages have suddenly showed up at C2. But what was in etcd may be state from, some time back. And so now C2 is wondering what's going on, right?
Well, so I guess it depends on where an ONU is in terms of stability, right? So if an ONU had gone through the whole bring up process, it's configured its services, and all it's doing is just collecting PM, for instance, right? I mean,
true.
In that case, it shouldn't matter, right? It's if it's not in a stable state, then basically once a new adapter starts handling that particular ONU, then if what's in etcd is saying, okay, it's still part of bring up, then really it knows that it's not stable and it has to start again with that ONU adapter, or it has to reconcile, I guess, with that ONU adapter when it comes back up, the adapter that was handling before, right?
Yeah, in principle, what you're saying seems right. It's just, I fear a lot of edge cases just popping up, right? And I doubt if you'll be, I mean, if you go through our, nightly regression tests, we'll end up in those edge cases once in a while, right? And trying to resolve each of these edge cases, like, oh, the ONU was in this state when the partitions rebalanced and now things don't work. But when the ONU was in that state, okay, yeah, everything seems like it's working. So we will always be chasing, I fear, these edge cases, when in principle, I'm all for the simpler solution that is still feasible, which is really just have separate topics per adapter.
Right. So what does that mean for let's say C3 goes away, right? And
yes.
all the ONUs that are associated with that C3. Now, what state are they in? Are they just running a lot? They can't recover. They can't add new services. So when the C3 comes back and reconciles, so it's going to have to restart the ONUs, or can it reconcile and keep them running, or?
So design goal of reconciliation, regardless if it's making C2 take over C3's work or C3 coming back, both of those are reconciliation activities, right? Both of those reconciliation is set up so that it is not meant to make any changes to the ONU, or as even little changes as possible to the core at all. Basically, in a reconciliation state, it says, I know I'm reconciling. I don't need to tell the core to add a port. The port's already there. I don't need to even tell the core to update a reason. Presumably, the reason that's there is still good. It's really just fill in my memory with everything I need to know to operate this device. Presumably, that ONU device is still running and still happy, and we don't want to change that. We don't want to sit there and have to push configuration for a device that really doesn't need reconfiguring. So if reconciliation still holds to that, then it's really just fill up my memory and don't change anything.
So the last MIB-sync value that was stored in etcd would be compared against that each particular ONU, right? And as long as that's the same, we're going to say, okay, everything's good. If it's
that's
different,
how it behaves, right?
If it's different, then we say, okay, we don't know the state, and we're going to have to go take this down to 0 and bring it back up again.
Correct, correct. So the scenario there is, let's say in the lazy writing world, we update an ONU, and before the lazy writer could write out the updated MDS, the ONU adapter died. So what happens is the adapter comes back up, its state says MDS is 23, the ONU says it's 24. In that scenario, then it goes through a resync. So for those ONUs that happen to be in that window of time where provisioning happened and 60 seconds didn't go by, they get a full resynchronization. At that point, it's an unfortunate scenario, but I mean, it's the price of lazy writing at that point.
Yeah, so that's no different from now C2 is handling that particular ONU, right? It's going to go to the etcd and say, okay, the MIB sync value is the same, so I'm just going to assume everything's great, and it can just keep going, right?
Well, so I guess it's the difference between two reconciliations, right? So in the scenario of a rebalance, what will happen is C3's devices will be handed to C2. C2 will see them as reconciliations and go through and fill up C2's memory with everything it needs to do to run those ONUs. And maybe nothing changes with those ONUs. C3 then maybe a minute later comes back, and then all those devices now have to be reconciled back onto C3 again. So again, C3 fills up its memory with all of those devices. Presumably nothing's changed, but now C3's back and can do its job. All we've done now is basically affect two sets of reconciliations, but the end result is really back to where we started, was C3's doing the job again anyway. If C3 restarts sufficiently fast enough, there's no reason to reconcile twice. You may as well just reconcile the one time you know you need
to. However, during that time, C2 will still have the old information.
It will. It will hang on to that.
And if C3 goes down, then any request to C2, they will think that this is the latest information.
Correct. Yes. So now C2 has got old bad information because it doesn't think it needs to reconcile.
Yeah.
So in this scenario, it ends up being simpler just to say, let C3 restart, reconcile once, and don't possibly confuse C2 with old data now and later.
And that's an edge case where C3 is going down twice, right?
Yes. And you can see that maybe in an upgrade scenario, for example. In an upgrade scenario, things may be restarting a couple times while they kind of get themselves sorted out. In that time, you know, with reconciliations or flying fast and furious, I wouldn't like to see the end state of that.
So basically what Matt, you are proposing is this kind of scenario when we actually have 3 topics, each one of them has a single partition and a single consumer.
Yes, yeah, I think, you know, the downside to this is you have to ahead of time know how to build this out. And the argument for that was typically in a PON setup, right? Your upper limit is a known quantity, right? You build out your ODN, you have a certain number of PON ports, you have a certain number of splitters with certain ports on it. You have a general idea of what the capacity is going to be for this pod on the top end. So maybe different locations have different expected capacities, but it's a predictable number. And at that point, it might be better to say, you know what, let's go ahead and build out 10 topics for 10 adapters. Maybe we only really need capacity for 2 adapters worth of ONUs, and then the other ones just sit idle. But we've at least simplified the day-to-day operation with kind of a bit of overbuilding ahead of time.
Yeah, so like I said, go ahead.
It also means it's currently in the core, the very first time a request gets sent to the adapter, it uses the device type as the topic. So if we have multiple adapters, it may still use the device type as a topic. It will just go to a general one, and whoever reply to that, it will have to reply with their own topic, the most custom topic. And from that, so you may need to have 2 sets of topics, one to handle like kind of a broadcast request and one that is very specific to adapters. And for anything that is specific, then when the request comes back, it will say, okay, from now on, use this specific topic. Then the core will have to keep that mapping between topic and device. So there's some changes there to make that happen.
Okay, but nevertheless, I mean, are we agreeing that the simpler approach is the more prudent one to take right now? I mean, the whole thing of, this making Volta simpler is something that we've been pushing for in this surge. So this topic per adapter, to me, it seems simpler than the rebalancing one.
I couldn't understand what information when new adapter saves in its memory, because when the adapter a device activation is completed, the only messages that comes from ONU adapter are the statistics and alarm information. So when an ONU adapter gets a message like that and it didn't have the device ID, so it can just, I think we can do something about it. That is the only problem that I can think of. But
I think the problem
there are some, yeah.
I think the problem is that happens if an adapter restarts while we are still configuring the MIB in the ONU.
Yes.
Once that is done, the reconcile it's easier and not that resource hungry. If I understood correctly what Matt said, the problem is that if we are
post-reconciliation provisioning. So when reconciliation starts right now, it's not only checking the MIB and restoring it so that you can query it. There's also the adapter keeps, again, variables in its own classes that say, I have a PON port with 5 gems that are assigned to these 3 TCON entity IDs. I need to remember that later, so when tech profile is either changed, removed, or an adapter is started and flows or changed or removed, it can go and find that without having to sit there and rebuild all of its memory again. The test for reconciliation is really continued provisioning. That's really where it shows its usage.
I think until we try both approaches and really look at it, it will be very hard to know whether one is much simpler than the other one. I think it needs to be tried out.
I would say if there's a way to sticky provisioning without any rebalancing. If you could have the partitions, the consumer stuck on the partitions, and it not reassign based on availability of consumers, it would effectively look like the same thing, right? It would just be everyone has their spot, and whether a consumer's there or not, it still partitions the same way. It's the rebalancing where things get unpredictable or difficult in working around, I guess.
Yeah, I agree with that.
So I'm not quite in favor of trying both approaches. I'm all for, speed of delivery and by the end of next quarter, right? By the June delivery, we need to have it working flawlessly at scale. And the period of time that, and passing all of our tests and really at scale. So if we have a gut feel that something is simpler and will avoid more edge cases, I'm all for pushing for that and making sure that works really, really well. And if we have time beyond that, right, then we go back and explore. Which is
well, I think to make such a big choice, we should at least try a draft implementation more than following a gut feeling. I understand not spending like 3 months evaluating both of them, but take a quick shot and see if it's actually that much easier to implement the multiple topics per adapter I think that we can do maybe 2-3 days, draft something and rediscuss it next week.
So from what I understood, there's actually, it's not just configuration changes, it's code changes that are required for either of those scenarios, and most likely different code changes for either of those scenarios. So who's going to create the drafts for both of those scenarios for you to try them out?
You are talking about these two? So
no, I'm talking about the one where you rebalance, and I'm talking about the one where you have different topics for different adapters.
Yeah.
The two slides that you had shown, right?
Yeah. So from a core perspective, the rebalancing itself, there's nothing to do with the core. But different topics, core will need to change some code.
What code would you need to change?
Because if it has to send a request to a specific topic, because currently we use, like, for example, when an OLT say it has discovered a device, it also sends the device type that it has discovered. For example, we say, oh, this is a Broadcom ONU, for example, and this is the device type that we use to figure out which topic to send the subsequent adopt device request. Now, if we have multiple topics, we will need to know, for the same device type, we need to know to which one to send it. And we don't really want they change the code in the OLT to say, okay, send it to this topic 1, right? So there's some way a decision has to be made to figure out which topic to send it to. So if the core has to send a request to a specific topic, then it has to change the code.
Yeah, this can be done during the multiple adapter registration, right? So when an adapter registered, also can say its topic, and then it can be saved in the etcd.
Now, it will have all the topics, but then when a request comes in for a certain device, it needs to know that this device is mapped to this topic, right? Currently, we don't do that mapping. We just use the device type. But the device type itself is not enough to differentiate between the different topics. So we'll need to have this change to have this map in the core if we go this way.
We can use a easy algorithm like, taking the module of the device ID and assign according to this. If you have 10 topics, you can take the modulo 10 of the device ID and
well, you can do a number of things in there. You can say, so to try this, you can hard code a bunch of stuff and make a lot of assumptions. You can say that.
I did change. Serkant is the one that made a change about this Kafka edits. So he may have better idea than me, but what I'm trying to say, according to the things that Ken said, when you send the Kafka messages to any type of module, in case you send the message to a Broadcom ONU adapter, you can put a very basic logic to that and say that we should send this message of this device ID to this partition. And
yeah, we can use some form of hash as long as it's a consistent hash.
Yeah, you can also say so if you do a test, you know everything up front. So you can say, I'm going to create 5 adapters, which will create topics that are BRCM, OpenNU 1, 2, 3, 4, and 5. And then when things come up, I'll send every ONU coming from port 1 and 2 to this topic, 2 and 3 to that topic. So you can do a fair amount of hard coding just to test this out. So it shouldn't be that much of coding change.
I guess we already discussed this implementation when William wrote a document, and we put some comments. But I just remembered that the biggest problem with that approach is both core and OLT adapter needs to have the same mapping, so that when the OLT adapter sends a message to the ONU adapter, it also needs to know which ONU adapter deals with the same device, which device. So I'm still thinking that with that approach, there could be more edge cases than with the Kafka rebalancing. Yeah, both approaches will have fair amount of edge cases, I guess.
Yeah. Well, all I was saying is that I don't know which one would be better, but I think we have to do a little more exploration in both directions for making a call, because the call that we do now is something we'll have to leave for the next couple of releases at least.
It's certainly from an HA perspective, this picture looks better, right? In terms of, I can maintain the ONU operational state using another ONU adapter. But I guess on the downside, we have to be careful that we don't get the situation where we have more than 200 ONU adapters for one. More than 200 ONUs for one adapter, right? So we have to be careful about how this might play out in a disaster situation.
Yeah, this situation will also be a little more flexible, I believe, because you can start with a smaller number of adapters and then increase it over time. Because it's true, what is the maximum amount of ONUs you'll attach to a setup, because that's a physical limit, but maybe you start running at 10%, so there is not really a reason to overcommission on the software side. It's also true that it's cheap to overcommission on the software side. So.
Another way to look at this, and this could be a little bit more code changes in the ONU adapter. It's in the core, when we're doing the core pair in an edge mode, what we have something called device ownership. So each core will actually own a device, and they keep a lock in the etcd from that, so that if there's and all of them will get a request at the same time, and whoever owns that device will actually proceed with it. The rest of them will just ignore, and in the core, because it's a pair, we'll wait if their one dies, and then we'll take over. But in this case, we don't even need to wait until everyone dies. We just make it strict ownership. So each adapter will own a certain set of devices. And if it goes away, then when it comes back, it will just look in etcd and says which one it owns.
So if the sticky partition can guarantee us that when all the adapters are back online, they'll be associated with the same partition as before, having this device ownership locked in etcd can be a solution, because when they get rebalanced, then C2 will just ignore every message coming from P3, and then when C3 comes back online, it'll get his device back.
Yeah, the only caveat I will say about that, it's to get it right, it takes time because there's so many edge cases that we had to deal in the core because of that, and also because here we're dealing with the Python adapter, so it's maybe a little bit trickier with the Kafka libraries in Python to be able to maintain something like that in the background, to keep polling to make sure it kept that ownership all the time. It's feasible. It's just like a little bit more work.
Exactly, and that's the point that I've been trying to make, right? So if you go back to that picture that I don't know that we were just looking at, right? I agree with what Sean said, right? This picture looks better, but having said that, the API server and the multiple cores picture also looked better, right? But we struggled with that with edge cases forever. And so at that point, with deliverability in time, right, with deliverable deadlines, we had to make the call to make Volta simpler. Okay. So if you want to explore both cases, fine, but realize that there will be a time where we will have to make a call and just go with one and try and make that better and solid. Both approaches are going to have edge cases, right? But your gut feel already tells you that one of those edge case, one of those should in principle be simpler to stabilize.
Yeah, and it sounds like from what Ken was saying, you could take this picture approach, and in a phase one, you maintain the relationship that, so whoever, C1, C2, C3, whoever owns a device, an ONU, that can't change. So you basically don't process any messages that you don't originally own, right? And then phase two would be, now you can take over for a while. If that makes sense.
Yeah, ownership is sticky and doesn't change. That's simple. In the core where it was getting difficult is when you have to switch over. That's when, and then you have to figure out, was the other side actually dies, or was it a real timeout, or was it a real failure case? That's when you have switch over. That's what makes it difficult. But if it's always sticky to own one, either I own it or I don't own it, that's a little bit simpler.
So I think if we can find a way to, for now, shutting down this picture to make it as static as this picture, it's a plus, because then we'll have the freedom in the future to make this very flexible without changing the abstraction. But I agree, we'll need to make a call and take the one that we can actually deliver in June. I'm honestly just feel that I definitely need to think a little more about that than making a call today.
Okay, well, okay, that's fine. That's fine. So what I would say is that you start together with Mahir and Matt and Ken, try and write a simple one-page design document of what either approach is going to take, right? We need to put it down on paper to try and understand, right? If we go with approach one, these are the set of things that need to happen. If we go with approach two, these are the set of things that need to happen, right? These are the caveats. These are the edge cases. At least write it down, right? So that it's in everyone's memory. Yeah.
We have a similar document. I'll go and start looking at it.
Are you talking about the document that William had started?
Yeah, that's correct. Because I think most of that stuff is there, so I'll probably, where is it? Well, I'll have to find it again, but it's somewhere here in the design doc.
Okay.
I agree, Sohrab. I think we need to, even before writing code, we need to look at the design, because I think just looking at the design and having more people taking a look at it will be able to fairly quickly figure out which approach is better to proceed.
Okay, I'm all for that. I just don't want to be in a situation in May where we still have, we're chasing our tail through edge cases. So, but I'm all for taking a structured approach right now. Just please keep in mind, we have a deliverable. So we need to get things real solid very quickly.
Yep. Okay, guys. Is there anything else we need to discuss on this topic?
We are discussing with Ken about the multiple adapter registration. I was planning to talk about the versioning also, but I think we have completed our time. So we will continue on that patch discussing that one. I think you are all getting the, because it's a draft, you may not be able to reach all of you, but if anybody else wants to reach that draft, I can share.
Yeah, if that's okay, I can put the link.
Yeah, that'd be great.
So let me find it. So if you cannot access, just bug second to have access.
Yeah, I think the multiple adapter registration is goes together with everything that we have discussed so far. So I think having this as part of the design document as well is, I think, is important.
Mm-hmm.
Okay,
Yeah.
but this will be pretty much the same for both of them.
Yeah,
maybe
exactly.
It will have a different data.
Exactly, it's because it's when we're talking registration here, we are talking about multiple adapters. So it's how we handle that in any cases.
Okay, sounds good. The last thing I wanted to throw there very quickly is that together with Volta 2.3, we are going to release version 0.10 BBSim. I feel like it's not the time yet to make a 1.0.0 just because the Deutsche Telekom and Dark Telekom workflows are not fully supported yet. So we should wait for those before releasing 1.0.0. Given that we are over time, if anyone has anything against this, send me a mail, a Slack message, or any form of communication. So if there isn't anything urgent, I'm going to call the call done.
Okay, thank you.
Thank you, guys.
Thank you.
Yeah,
Was a good call. Talk to you soon.
Bye.
All right.